Winter 1944. Over occupied Europe, the air war had become a war of exhaustion. The Reich still fought, but its strength was bleeding away mile by mile, bomb by bomb. Every morning, the skies above Germany filled with the sound of American engines, thousands of them. Bombers from England, loaded with explosives, climbed in formation toward the heart of German industry. For months they had flown without protection, taking losses so severe that commanders questioned whether the daylight bombing campaign could continue. Then came the aircraft that ended the argument forever, the P-51 Mustang. The first intact Mustang captured by German forces was serial number 43 to 12,102. It came down in early 1944 near Bad Zwischenen after its pilot bailed out with an empty fuel tank. The plane was remarkably undamaged. Luftwaffe technicians recovered it, photographed it, and shipped it to the test center at Recklen, north of Berlin, where all captured Allied aircraft were examined. Engineers, pilots, and officers from the Reich Air Ministry gathered to see what the Americans had built. What they found changed the way they viewed the entire war in the air. The Mustang did not look like a weapon born of desperation. Its aluminum skin was flawless, its rivets recessed, its panel lines tight. The laminar flow wing, still a mystery to many German designers, reduced drag far beyond what the Luftwaffe's current fighters could achieve. The surface finish was so smooth that Recklen engineers measured airflow by touch and found almost no turbulence across the upper surface. The P-51 weighed less than most German fighters, yet carried more fuel, more ammunition, and could stay in the air nearly twice as long. Its build quality reflected not only precision, but consistency, the mark of a nation that had mastered industrial repetition. The engine attracted immediate attention. Beneath the cowl sat the Packard-built Rolls-Royce Merlin V1650-7, a 1,490 horsepower 12-cylinder engine built under license in Detroit. When German engineers disassembled it, they noted how every component could be removed and replaced easily. Bolts, lines, and fittings were standardized. Manufacturing marks were identical across all pieces, proving that hundreds of factories were producing interchangeable parts with microscopic tolerances. The Germans had spent years refining the DB-605 and Jumo 213 engines for their fighters, hand-fitted machines built by craftsmen. The Merlin looked like it came from an assembly line, yet ran with a smoothness their own engines rarely achieved. The two-stage, two-speed supercharger impressed them most. It maintained full power at altitudes above 25,000 feet, where Luftwaffe fighters gasped for oxygen. In test flights, it ran at high boost for over an hour without overheating. The first Recklen report described the aircraft's performance as überraschend, astonishing. Test pilot Hauptmann Hans Werner Lurk flew the Mustang against a captured Bf-109G and FW-190A. The results left no doubt. At medium and high altitudes, the P-51 outclimbed the 109, matched the 190 in roll rate, and outranged them both by hundreds of miles. With external fuel tanks, it could fly from England to Berlin and back, escorting bombers the entire way. German analysts understood what that meant. The days of safe production, repair, and fuel movement inside Germany were over. For the first time, Allied fighters could strike anywhere, anytime. The Luftwaffe had known about long-range Allied aircraft from intelligence reports, but the physical evidence was worse than the rumors. Engineers studying the Mustang's fuel system discovered a self-sealing network of tanks totaling 269 gallons, augmented by jettisonable drop tanks under each wing. The internal plumbing was arranged so that fuel drained from external tanks first, then from internal cells, keeping the aircraft balanced through the entire flight. The system was simple, durable, and completely reliable. Every line was labeled, every connection standardized. In the same period, German engineers were still struggling with fuel feed problems in the new Me-262 jet, whose delicate pumps often failed after a few hours of operation. The Recklen aerodynamicists documented the Mustang's cooling system with particular fascination. The ventral radiator duct, which at first appeared to be a drag penalty, produced a small amount of jet thrust from its hot air exit flow, a phenomenon known as the Meredith effect. German reports measured this thrust at nearly 150 pounds at full power, enough to offset most of the radiator's drag. It was elegant, efficient engineering, achieved not through exotic innovation, but through meticulous testing. In their private notes, several engineers admitted that such design refinement could only come from a nation with massive research resources and near unlimited access to wind tunnel data. By March 1944, Recklin's findings reached the Reich Air Ministry. The summary was grim. This aircraft represents the culmination of Allied fighter design. It combines high-altitude performance, range, and reliability beyond current German capabilities. The memo was classified secret and circulated among senior technical officers. Discussions began on whether a German equivalent could be built using the DB603 engine, but the idea was abandoned within weeks. There was no aluminum, no fuel, and no time. The American factories could produce 500 P-51s per month. German industry, under constant bombing, could not keep a single plant safe for 7 days. Luftwaffe combat units soon confirmed what Recklin's engineers had written. By spring 1944, formations of P-51s were appearing above every bomber stream. Pilots who had once chosen their engagements now found themselves on the defensive from takeoff to landing. The Mustangs hunted far beyond their escort missions, sweeping ahead of the bombers to clear the skies. On March 6th, during the first large daylight raid on Berlin, Mustangs from the 4th, 354th, and 357 fighter groups claimed nearly 70 German aircraft in one day. Losses among German fighter groups were catastrophic. Veteran aces who had survived years of combat in North Africa and Russia were dying over their own cities. The Luftwaffe's last strategic reserve, its experienced pilots, was evaporating. At Rechlin, the test continued. German engineers analyzed the Mustang's gun sight, radio system, and cockpit ergonomics. Everything was arranged for efficiency. The cockpit was spacious and well ventilated, with instruments grouped by function. The throttle and propeller controls were large and positioned so that pilots wearing gloves could operate them easily. The K-14 Euro gun sight allowed accurate deflection, shooting at ranges where German pilots still estimated by eye. In every small detail, the American fighter seemed designed not for the ideal pilot, but for the average one. That philosophy, engineering for the ordinary, was alien to the German system, which assumed elite skill and constant training. By 1944, those assumptions had collapsed. The Luftwaffe was filling its cockpits with teenagers. The Mustang had been built for exactly such men on the Allied side. Ordinary, trainable, and replaceable, flying a machine that minimized human error. The Rechlin mechanics were equally impressed by the ease of maintenance. Panels came off with quick-release fasteners. Spark plugs could be changed without special tools. Wiring looms were color-coded. The aircraft systems were so modular that an entire engine change could be completed in under 4 hours. German fighters required days of work for similar repairs. Even the paint, or rather, its absence, told a story. The unpainted aluminum skins saved weight, simplified production, and reduced corrosion thanks to advanced alloys. It reflected sunlight, making the aircraft harder to spot at high altitude. Every design choice, from rivet to radiator, served purpose, efficiency, and economy of effort. By summer 1944, the strategic impact was unmistakable. With Mustangs escorting bombers deep into Germany, the Allied air offensive reached full power. Synthetic fuel plants at Luna and Politz were bombed into silence. The Focke-Wulf and Messerschmitt factories at Regensburg and Marienburg were reduced to rubble. The Panther and Tiger tanks being built on the ground no longer mattered. Without aviation fuel, they could not move. Allied commanders had achieved what the Luftwaffe once believed impossible: complete control of the air. Inside Germany, the technical community tried to fight a war of reports. Engineers drafted memoranda proposing jet interceptors, rocket aircraft, desperate solutions to a problem that had already been solved by the enemy. The Rechlin evaluation of the P-51 was updated again in late 1944. It concluded, "The aircraft demonstrates an unmatched combination of performance, simplicity, and endurance. Its industrial reproducibility is beyond our capacity under present conditions." Privately, the head of the Luftwaffe testing department wrote a single sentence in his diary: "The Americans have turned engineering into mass art." In the final months of the war, Mustangs ranged unopposed over central Germany. They strafed trains, fueled depots, airfields, and convoys with impunity. Luftwaffe airfields became death traps. Ground crews learned to scatter at the first sound of Merlins. In April 1945, as Allied forces crossed the Rhine, Mustangs flew 8 sorties a day, each lasting hours, without a single mechanical failure reported. The Reich's last surviving P-51 test specimen at Rechlin was destroyed by bombing days before Soviet troops arrived. The engineers who had studied it fled west, carrying notebooks filled with data that would later reach American intelligence teams. When Allied technical officers examined those files, they found meticulous respect. The German engineers had measured, photographed, and diagrammed every system with scientific precision. They had written candidly about their admiration and their envy. One line from a February 1945 document stood out. This machine represents the victory of industrial organization over individual genius. It was not a compliment. It was an epitaph. After the war, many of those same engineers worked for new governments. Some joined the French and British research establishments. Others went to the United States under Operation Paperclip. They studied the P-51 again, this time as collaborators. They saw how its lessons had already passed into the jet age. The focus on reliability, simplicity, and range. The first generation of post-war fighters, including the F-86 Sabre, borrowed directly from its aerodynamic principles. The concept that engineering must serve logistics, not vanity, became doctrine across the Western world. The P-51 Mustang did not win the war alone, but made victory possible. It was the physical proof that America had achieved total mastery of modern war, not through exotic technology, but through disciplined engineering and limitless production. It carried that advantage from one end of Europe to the other, mile by mile, mission by mission, until no German airfield was safe and no pilot believed survival was possible. When the war ended, the Mustangs were still flying, still ready, still perfect. In the ruins of Rechlin, a burned report cover was found among scattered papers. The title, still legible beneath the soot, reads simply, Untersuchung der amerikanischen Jagdflugzeugs P-51B Mustang. Inside, the first line of the introduction had survived the fire. This aircraft represents the highest state of operational reliability yet observed. No propaganda, no excuses, no denial, just a final, precise German sentence acknowledging what every pilot in the Reich already knew. The Mustang was not just an airplane. It was the end of the Luftwaffe, engineered with American calm, built with American steel, and flown by men who would not turn back.